This video will accompany the investigation that we done today in class, so for anyone who missed it or would like further explanation on it, put this together. So we're going to look at an area problem, and what we have here is that you have a puppy, you want to keep it safe when it's playing outside, so you're going to end up making a pen. And you would like to have the pen so that it's the largest area possible. So we're going to give you 60 meters of fencing, and let's see what the biggest area that you could make. And we need to have those dimensions. And I'll just use my chart here to do some sketches, and I'll erase them after. Alright, so you got a length of 0, and what would your width be? Well, that probably doesn't seem to make sense. How can you have a length of 0? Well, really you can't. If you had 60 meters of fencing, and the shape that we're going to use here will be rectangles. So if you just think about this, the width, and if I get 60 meters, but really what happens is that if you cut the 60 meters of fencing, so straight line of fencing, you cut it in half, you'd have 30 on top, 30 on bottom, and you'd find that you couldn't actually make a pen because you don't have anything to block in the left side or the right side. So that's a little bit of a nonsense there. You can't really make this. So if you tried to have a width of 30, it wouldn't work out because the two ends will be open. So your area would be 0 times 30, length times width, and 0 meters square. So that one doesn't really work out. So we'll just get rid of that. Alright, well, if we had a length of 5, and if I just let one block be 5, another block's going to have to be 5. There. Because I would have a top, have a bottom. We're making our pen, so letting the back be 5, say the front be 5. And right now I've used up 10 meters of fencing, so we only had 60 to begin with. So 60, just use 10, so that leaves me with 50. And that 50 has to get split over the left side and the right side. So I should have 1, 2, 3, 4, and if I want to make it somewhat to scale, it should have been down there. So for your dog, it has a pen 5 by 20. And your perimeter should add up to give you 60. 5, 20, 5 here, and 20. That's your 60. So the width is 20. Area, length times width, 5 times 20. Sorry, 25. I don't know why I said 20 there. So 5 times 25 will give you 125. Okay, let's make your length 10. So I'm making my length 10. Well, it's got to be 10 on the top and on the bottom. So now you used up, out of your 60, you've just used up 20 meters. So you had 60. I used 10 for the top, as here. And that means I use 10 for the bottom. So I have 20 gone. Leaves me with 40 meters. And that 40 meters has to get spread over the two sides, the left and right. So each one now has to be 20. So 5, 10, 15, 20. So that's 10. This is 20. So length of 10, width of 20, 10 times 20, and I get 200. All right, what happens if we go to 15? And there's a pattern to here. Look at the numbers. So 15, you go 3 blocks across. If we were just going to let each one be 5. 15, well, you had 60 meters. I'm using 15 for the top, 15 for the bottom. So I've taken away 30, leave me with 30. That means that the two sides here are going to have to be 15 each. So I end up with a square. 225. And if I keep increasing my width now, decreasing my width, and now I go to 20, well, 1, 2, 3, 4, that's 20. I use 20 for the top, and then 20 for the bottom. So let me just give myself a little space here to sketch. I use 20 for the top, 20 for the bottom. That's 40 gone, leaving me with 20. So then my two sides have to be 10 each. And what you start seeing is that really the figures are repeating themselves. So this is my maximum area. I got 10 by 20. Well, that's the same thing as 20 by 10. It's just that they're turned. And then my last one, here, 20 by 10, 200. So our areas are now repeating. And then my last one, that will be 5. So I'd have one that had a 5 here. And then it would have to be 25 going across. So let me move that over. So if I let this side be 5, that one's going to have to be 5, and then it's 25 going across. So you're not really getting different shapes, it's just they're turned. And 25 times 5, 125, 30 times 0, 0. Okay, so let's graph this. And we can look at our graph and see which one gives us the biggest area. Let's keep our numbers so we can see them, and there's a point here. So when graphing, remember to label the axis. So that's your y-axis here. And we also have our x-axis. So labeling, we have two variables here that we want to look at. One, and they're going to be length and area. So we want to see the effect of length on the area. Length is going to affect area. So as you see here, as you change the length, the area changed. So length affected the area. Well, and we can get a whole conversation about independent and dependent variables, but we'll leave that for class. So my length I'm going to put here. And my area I'm going to put here. And area is in meters squared, and length is in meters. And let's pick a scale that's going to work here. So we're going from 0 up to 30. So I think if we let every two blocks be 5, 5, 10, 15, 20, 25, and 30. We probably could have went a little bit bigger, but this will work for us. And then our area is going to go from 0, and the biggest number we have is 225. And we could try something like going up by 50s or 75. We want to be able to fit this in so we're using up the most space we can. But we don't really see a change in our numbers until we get to 125. This is the first solid number we have. Then it's 200, 225, 200 again, 125. What we can do, and some of you mentioned this in class, and you see from science, is use a break line. So we're going to condense some numbers because we don't have anything from 0 up to 125 before that. So we're going to start here at 100. And then if we let everything be 25 after, we can quickly see if we can, every two blocks, 125, 150, 175, 200, 225. So we can get that to work. So this will be 125, 150, 175. We'll just move that. And we'll change the label after. 200 and 225. And this will be your area in meters squared. All right, so let's graph this. I'm going to start here, and we'll fill that in after. So when your length is 5, your area is 125. So when your length is 5, your area is 125. When your length is 10, area is 200. When it's 15, area is 225. And you could write these because these do represent ordered pairs. So 15, 225, 10, and 200. That will be 5 and 125. And then when we get the 20, there's 200 again. When we get the 25, it's 5. So at 20, it's 200. What is that, 25? It's back down to 125. And 0. When it's 30, the area is 0. And here, I'll just fill that one in from the beginning. When the length is 0, the area is 0. So what we have here now is, if we connect the dots, we would find we have a quadratic. All right. So what dimensions give you the maximum area? Well, dimensions that give you the maximum area are 15 by 15. So we'd seen that. And with these problems, the shape, if we're talking about a rectangle, would always end up being a square. So what is the maximum area? 225. We got that from a chart. What's the shape of the graph? Well, the graph is a quadratic or parabola. Now, we have an axis, symmetry, and vertex. And what do we learn from them? Well, let's draw in our axis of symmetry. So it should be something we learn from this. And what we find is that, keep in mind, you only have 60 meters of fencing, so you have a limited amount of material. As you increase the length, the area will get bigger. But if you increase the length too much, the area starts to drop. And you see that here. Because as you're increasing the length, the width starts to get smaller. So there's a trade-off, and you just end up repeating shapes. So you can increase the length so far, but by then you're not going to get any benefit out of it because you're just shortening on the other side. All right, your axis symmetry now, when we look down through here, and your maximum area is here at the top. So if we just look across from there, we get our maximum area. So your axis of symmetry, when it cuts down through, your axis of symmetry is telling you the length that gives you the maximum area, and your vertex ties it all together. It's going to tell you the length that gives you the maximum area, and it's going to tell you the maximum area. So at this peak here, at your maximum, you get your maximum area, and you're finding out, if you look down, well, this is a length. It tells you the length that gives you the maximum area. So you get two pieces of information from that. So from here, what do you learn from the axis symmetry? The axis symmetry will give you the maximum length. Well, I shouldn't say maximum length. Really, it's the length that gives the max area. The way you learn from the vertex? Well, from the vertex, you get the length and the maximum area. So just repeat that again. You find out that the length is 15 meters. That gives you a maximum area of 225. Okay, that's it for that one.